Divya, you are on mute if you are talking something.
Now you are telling I'm talking from 6 minutes. I'm sorry for that actually. I'll come back. That is what I'm thinking. Nobody is responding what happened. It's okay. So whenever we use transformation, what it will do? It will return into an RDD, right? Yesterday we discussed it. So RDD is immutable and stored text files and log files. That one we have discussed. And whenever we are creating an RDD and we are using lambda function, by using the map, what it will do? It will read each value. This map will read each value. So each value is nothing but what? I'm having 1, 2, 3, 4, 5, 6, right? So when I'm using map function, indexing 0, 1, 2, 3, 4, 5. Like that, it will go to each and every value and it will read it. Okay.
Yeah.
What is the output of a transformation? What is the output of a transformation? So whenever we use actions, it will return result set. Yesterday we discussed it and we have seen that by executing that, right? Whenever we use actions, it will result in a result set. What is that result set? It may be any variable or any collection. Variable or collection. That is why nobody is talking. I thought what happened. Okay. Whenever we use return RDD, RDD is immutable. It will return RDD.
New RDD.
New RDD, that is right. So this thing yesterday we have discussed. So we are using filter means it is a where condition in SQL. If I'm using filter, which is nothing but a where condition. Okay. So one more thing we need to remember. Filter won't return any data. Filter won't return any data. What it will return then? It will return true or false. Will return Boolean value. Either it is true or false. Now, till now, what we have seen in the yesterday class, all are narrow transformations only, right? No different, like what is narrow and what is wide. If the
Wide.
number of stages or one,
That is the transformation.
stages or one, then it is narrow transformation. Narrow transformation is nothing but there is no shuffling.
Right.
No shuffling. No shuffle right, no shuffle read. No shuffling. Now let's understand what are the wide transformations. So now let's try to understand PySpark. I'm just giving everything on the RDD. Mostly we'll finish RDD in this class or in the next class also it will take 15 to 20 minutes. Later we can shift to data frames. Okay. So PySpark RDD, wide transformations. So if the job is single stage, then it is job single stage, then it is narrow. More than one stage,
Wide transformation.
wide transformation. Wide. Let me go to the Databricks workspace. And one more thing, yesterday I want to show you that where the file is located exactly. And it has thrown error, right? Here we got illegal exception, cannot head a directory. Why we got like this means actually the file is stored in this location only. The issue you got is whenever you are using pickle file, that pickle file is going to be stored as Parquet format. Parquet format is nothing but in partitions it is going to be stored. Why? Because we are using serialization and deserialization at backend. So this file is stored in the Parquet format. How it looks in the Parquet format, you need to, if you want to see that. And one more thing, now if you want to try to create RDD, you need to create when the cluster is on. But in this location, the file already I have saved, right? In the location, the file would be there. So saved files would be there in the same location. If I'm trying to execute same thing, it will throw exception because the file is already existing at the particular location. Okay, I just, one second, I'll define this. So this is the RDD we have created. RDD file is equals to sc.txt file. This is taking from the pre-given data sets by the Databricks, and I'm creating RDD. After creating the RDD, I'm just trying to get the data here. Okay, I'm saving the file. Now I'm trying to save this file. It will throw an exception because, see, you can see here, the data, the file already there, already RDD underscore data text file, pickle file already there, already exists. That's why it is not creating. What it means, if you have created RDD in the community edition and you left that cluster, you are not there. So this, whatever we done the coding, that won't be existing on the cluster. But we saved in one location, right? That location, the file would be available all the time, even the cluster is on or off. Okay, now I'm trying to get this file. So yesterday what I have tried, I just tried by giving the head. Head is nothing but to read that file. I'm just giving this. So it is giving the illegal argument. Why it is giving like that means whenever we are using pickle file will store the data in Parquet format. Parquet format is nothing but which is the partitions. So the data would be divided into partitions. Now if you try, see, now also we got the same error. So now percentage FSLS, I'm giving the file path which I have created here. So I'm executing this. You can see we are having success. This is nothing but whenever you are, this we can discuss whenever I'm trying to go for the big data types. But here I just give you the glance so that you can understand. No need to get confused. Whenever the Parquet file is start saving, what will happen is this file, it will generate one log. That means I'm trying to save this and it got succeeded. So this is a log entry. And you can also call it as audit log. So you will see that success. Okay, it's storing. Now, how we can do that? I'm just copying this path, trying to execute this. Head means to read that. So see, this is a file, and is it readable? Somewhat it is readable, but the thing is it has stored in the partition format. Original file looks like this. We have seen already this. Original file looks like this. This is the original file. But what happened when we are trying to load that file by using pickle file? I have read that by giving the path. You can see this file is encoded. So this file is encoded to some other data type. That's why you are not able to read all the data. It looks like that because it is in any big data file format. What we'll do is, we have already discussed this concept, but I'm telling you. So it will compress and load. So you don't get all the data. It is compressed. This question marks you are seeing, right? This is the compressed data. So 99%, 98% by using Snappy algorithm, all the data is compressed and saved in the location. That is what you need to understand. So whenever I'm giving the pickle file, it is storing it in the partitions. And we tried with normal file also, right? This is a normal file we have tried. I'm just trying to execute this. What will happen now? It will throw the exception because this file is already existing. So let's check this file. How to check that? I'm just giving percentage fs ls and the path. Like how I have given here, the same way I'm giving the path. This is for text file. So see, for text file also it is stored in the partitions. So what we need to understand is any big data file, it never going to be stored in like it is already defined RDD inside. So the it has to be stored the data into the partitions, which is nothing but Parquet format we are using. Okay, we can understand we are having three kinds of big data formats. One is Parquet. Parquet, that is, I'll write here the name. We'll write like this, but we'll read. Okay, Parquet format. And second one, we are having Avro, ORC. So these are the three big data file formats. Three big data file formats. So it will store in the partitions. All three files will store in partitions only. But whenever, mostly we will use Parquet only. Parquet can be used in all things. Parquet and ORC both are columnar storage. I'll explain you. We can understand that in the future. So Avro is only row format, which is used for streaming data. So whenever we are using streaming data, we can use Avro. Streaming data can be used by Parquet and ORC, but Avro will give you the good results compared to the Parquet and ORC. So Avro is a row format, Parquet and ORC columnar format. The data stores in column like it will store by column. But here, whenever you are trying to write streaming data, it will store in row format. These three are big data file formats. We will go deep dive. Okay, but now you just understand that. That's it. I'm just trying to create PySpark RDD wide transformations. So single stage narrow, more than one stage wide. Okay, I'm creating one RDD. Is it clear up to here? Like storage part?
Yeah, Divya.
Okay. Just creating one MD. How to create? Either it is percentage MD or you can give it here also. PySpark wide transformations. It will come like this. So just create one RDD equals to sc dot parallelize one comma two comma four. One partition I'm giving. Okay. So just execute this, which is a lazy evaluation. So you don't see any output over there. Just creating RDD map function, RDD dot map lambda A plus 100. I need to give any action to trigger this. Okay. Dot collect. So for each and every element, 100 is going to be added. This is mapping to each and every element. And how many partitions I have given? One partition. Glom. How to check that? Total one partition it has taken in a single partition. Let's understand map function. Okay. Suppose I'm having an input RDD. And a map function. Output RDD. I'm having number of partitions. I'm taking 3 number of partitions. 3 number of partitions data. 1 to 9 I'm taking. This is the RDD. So here what I'm doing, I'm writing function map lambda is to a plus 100. So for this, what will happen? We will get 100 need to be added to each element, right? So 1 for 100. And what would be the output RDD? 101, 102, 103. Like that, we will get the output RDD. So this is single stage. We are having only one stage operation. Okay. 104. We do understand till here. Like we are doing mapping function. So we are adding each and every element to this value which we have given in the lambda function. So map will do the mapping to each and every value, whatever function we have given inside, what we are saying, A should be added with 100. So A is nothing but it will iterate through the loop like for loop, and it will add each and every value to this. So we need to understand what is a filter function now. So this is the output RDD we are having for the map function. So filter, suppose I have given what filter function we have used here. You see, A is to A percentage 2, which is nothing but A by 2 should be equals to 0, right? Percentage is nothing but whatever the coefficient we have received, that is the value we are getting, A percentage 2. So I'm trying to get that. So whenever we are calling this to here, 101 by 2, what is the output we will receive? 1, right? 101 by 2. Percentage is nothing but the value which it will return. So it would be 1, which is nothing but odd, right? So odd, when it is equals to 1, which is nothing but it is a false condition for it, right? So false condition is 101 by 2 equals to 1, but we require equals to 0, which returns which value? It will return the false value. This thing to get understand, I have drawn this. So whenever you are giving filter function, this filter function will return only true or false. Filter only returns true or false. Again, for the 102 by 2, it would be true. Because it is 0, it is true. Like this, it will read all the values. This is a filter function. And filter function is nothing but what? Filter function is a narrow function. Now, what would be the output RDD? Output RDD, I'm not drawing everything, it will take time. So output RDD would be, finally, what you will receive here, you will receive same, this one, right? One not one, one
Even numbers.
yeah, whatever you have given, that would be there in the output function. 102, 104, 106, all even numbers, right? So 7, right? So these are the output RDD which you have received. What happened here? Whenever you are doing the lambda function, it is doing parallel processing. What it is doing? It is doing parallel processing. This thing you need to understand. So read each value and returns one RDD. In the filter function, what it is doing, it is giving only true or false, and in the output RDD, you are receiving according to your condition. Here I have given the condition even, so you will get even values as output. This is what the narrow transformation, and we are having filter and map. What we have understand, all these are lazy evaluations. Who will maintain these lazy evaluations? That's what we need to understand. Who will maintain this? This lazy evaluations are maintained by DAG scheduler. I'll show you what is DAG. If you see here, what happened, we are having Spark jobs. View this. Try to view this. Just now. I'm just trying to view this. So if you see who were doing all these things, lazy evaluations. Lazy evaluations is done by the DAG visualization, which is a DAG scheduler, shows a graph of stages executed for this job, each of which can contain multiple RDD operations. Example, map, filter, and RDDs inside each operation. What we have given in this DAG scheduler, we have given lambda. In this, we have given map and filter. It's showing the same. Shows us dots. Why it is dots? Because it is a Python coding. For each and every function, we need to connect it with dots. So who are taking all these lazy evaluations? It is controlled by DAG scheduler. This part is very important in the interviews. They will ask you, whenever they were asking you, what is the Spark architecture? You will explain everything. What you will explain, we are having master node, slave nodes, and in between we are having one resource manager or cluster manager. What they will do, it will understand the slave nodes behavior, which one is available, which one is not available, and it will, from the master node to slave node, what will happen, it job to piece of code, 2 stages. This is all the Spark architecture only. Stages to tasks. So each task will be assigned to each node. Who will assign that? That can be done through resource manager. This is one part of Spark architecture, and each node, right? Each node will give task to each node. But one more thing very important that you need to explain is Spark supports lazy evaluations, and this lazy evaluations are controlled by DAG scheduler. This is very important. They will ask you DAG scheduler. Okay. What is DAG? Directed acyclic graph. This is nothing but DAG. So who is taking care of all the lazy evaluations is DAG scheduler. Directed acyclic graph. This can be do the all lazy evaluations. See here. You can click on that. You can see what is that stage and how it is working. By looking at it would be easy, and it is like that, but it's not that easy to understand. So what it is doing, this is a DAG visualization, which is nothing but what DAG is doing exactly. It is doing parallel collection of RDD, okay, reading through the input stream at Python RDD. So this is backend Python RDD with the Scala. It is a backend thing. And it has given to one RDD and it is giving the output. This is all what? Parallel. Parallel is why it is parallel. We are using lambda function. Lambda function will read all the input stream parallelly. So, and summary of metrics, what we are having. How many tasks it has completed? 8 tasks it has completed. Why taken 8 tasks? Anybody from you? It has taken 8 tasks
Because default 8 part.
default 8 partitions. Very. So these are the entries for our work, what we have done. We have created one RDD, just a simple one statement we have done. Nothing, we didn't do any hard work here while writing. But see how Spark is working backend, how much work it is doing. So it is taking each and every index 0 of each and every element, and is it trying to attempt and it will succeed, and then it will store the driver. Driver is nothing but whom? Driver node or master node. It will take, okay, and it will host through one IP address, and all the logs are stored. What is the time? What is the duration? What is GC time? GC is nothing but garbage collector. If garbage collector is not working, memory. If garbage collector is not working properly, then you will get out of memory exception. This many entries are there. This much work is done by your Spark at backend. These are stages, and you can see the jobs. These are the jobs done for one particular RDD, that is mapping. And you can see these are the jobs which are done today. These are the stages. And only for, you can see filter function, lambda function, you got 8 by 8. Because in the RDD data, I didn't mention anything. But when I'm creating something, I have mentioned only one particular partition. So like this, it is going to, these are the jobs. And this is all comes under Spark architecture only. So Spark architecture is nothing but you just drawing one diagram. It is not like that. You need to understand what is going on at the back end. This is the event timeline. If you got some time, you just try to create one RDD and you try to understand all these things. See, executed driver added at this particular time. It started running. Scheduled mode, fair. So how much time it would be? Uptime would be 30 minutes. This is job stages. And how the storage would be, let's understand. Any external file system we are reading data? No. IO caches? No. So nothing is there here because we did simple work, because that's why we are not having. If we load big files and all, then we will have all these things. This is the environment. You can see everything. Runtime information. What is running? Java. Backend is Java. And it is a Scala version. Why? Because each and every node, what it is having Java virtual machine along with the cache, right? So this is the thing. These are the Spark properties. And we are using community edition. That community edition is provided by your AWS. But those who are working with free edition, they can see their environment. I think that is by Databricks. You are on, you have on your system, right? It's parallel working. Then you can check here what is the environment. It's true. All these things you can see. Cloud provider is AWS. And your cluster usage tags, all clusters. What is your cluster name and workspace value? Everything would be given here. This is very important. Why you need to understand is, this is your workspace value, because in coding sometime we used to use this value to point out to this workspace. The same value you can see here in the, here also the same value, right? This is a cluster value where you are seeing. This is all about your environment. And you are using, whenever you are trying to create your cluster, it will ask for the region. Which region? Now we are using the US West 2 region. And runtime engine is standard one. So this is, we can see whenever we are trying to create our cluster. So this cluster is having, this is a 12.2 version, Spark 3.3.2 Scala backend. And here, whenever you are trying to create one new resource, it will, not here exactly, but whenever you are trying to create in your paid version, you will have which location you want to do that. That cluster is available there. So what happened is whenever it is available there, it will use the resources from there. Okay, use these executors. This is all Spark architecture. The entire backend thing is the Spark architecture. So active, you are having storage memory this much. Disk, we are not using any disk, right? Because we are doing everything in the
In
memory.
memory.
In memory. That's why disk is 0. But if I'm connected something to C drive or something to my personal laptop drives or anywhere, you can see the disk memory also there. And number of cores are 8 cores. So 8 failed active tasks and executors it will give. So total completed tasks 10. For the garbage collector, how much time it has. If you hover your cursor, you can see shared red when garbage collector time is over 10% of task time. So if it is more than 10% of task time, it is going to be in red. Input, shuffle rate. So if we try to create one Y transformation, we can see how many bytes it is going to be, shuffle read and shuffle write. This is what executors will do. You can select how many. This is the storage memory. We have used 19.4 kilobytes for our RDD creation. You can see all your data frames and all here. Whatever we did the work, that would be displayed here. Even some people done some work and they left on that particular cluster, if you want to see that, you can see it here in your DAG scheduler. But what happened is, for you, I think in your organization they will block this, they don't allow you to see. But if you have the permissions, you can see it here. Who admin can see all these things. But here in community edition or free edition, we are the admins, right? That's why we are able to see all this. This is a JDBC server backend, and we are seeing structured streaming, but we are not doing any streaming. That's why it is not showing anything. This is all about your Spark architecture, how the jobs are running at backend. We will see one by one when we are trying to write wide transformations. For narrow transformations, it would be like the same. You don't see anything because no shuffle right, shuffle read. So next one we need to understand is flat map. So what flat map will do? Till now we have discussed map. So map will map each and every value and it will give you the output exactly. But what flat map will do? Flat map will give you, if you are having output is nested, then only we will use the flat map. We can see the difference. Once after completing RDD, I'll share this notebook with you so that you can work on this. Even if you are not having community edition, that is fine. Don't worry, but try to understand the concept. We can understand this RDD. If you are not able to practice, also fine. Data frames are important for us. I'm just trying to give the flat map. Flat map function. So for this, we are having on RDD. I'm just specifying on RDD. The same RDD I'm using. RDD dot flat. See, I have got it. Flat map. Inside that, instead of map, I'm giving flat map. Lambda. plus 20. What I need to call what? I need to call the function. So this is what the output for this RDD. So each and every RDD. So RDD, what we are having 1, 2, 3, 4. For each and every element, it is adding 10 and 20. And just again, this is all nested output you are getting, the multiple output values you are getting. For that, you can use the flat map. Okay. So suppose if I'm doing the same thing for the map function, RDD map lambda. Just giving a, previously we have worked with only one. Here I have given just, it's okay. The same thing. Nothing in it. A dot collect. I have given flat map and map. Map and flat map both are narrow transformations. Both are narrow transformations. No shuffle right, shuffle right. What is the difference you find here? This is flat map function, this is map function. Here you
We
got
have
into
different
different
groups.
partitions. Yeah, groups 0, 1, 2, 3, or four partitions, but it has given in the sequence. Whenever we are trying to write flat map, it will give you the sequence. Output is same only, but it would be easy to understand here rather than here. It looks like different sets, but here it will come to you like a flat answer where you want to see exactly. Okay, this is only the difference between map and flat map. This question will be asked in the interview. What is the difference between map and flat map? The map takes one input element from RDD and results with one output element. So the number of input elements will be equal to the number of output elements. In case of flat map transformation, the number of elements will not be equal. That is the difference. Understand? Here how it is loading in the same way it is giving the output. It is loading in the same way how it is loading. So when I'm trying to give the, suppose if I'm creating this, right? I just want the gloom function. It is taking as sets here, but here it is giving the flat answer. That is the only difference. Whatever it is taking input here, it will give you like that. Just understand, we are having RDD 1, 2, 3, 4. So 1 is taken here, and again 1 plus 10, 11. Okay, so it will come here again 20. 1 plus 20, it will come here 21. So it is making us one set. And you next one, wait, I'll give you in the paint. You understand or shall I explain it deeply? I'll give you if you want in the paint.
Yes.
What is our RDD1? 3, 4. This is our RDD we are having. And we are having one more, that one is map function. And inside that we are having lambda. In the lambda function, what I want to give, a plus 10, a plus 20. So we need to add 10 and 20. So one thing it will do, how it is reflected, you can see here, it is coming all ones added here. Okay.
Hey, what's up?
So one is added here.
Yeah. Probably.
Yes, it would become 11. 11, again 20 added, it would become 21. This became one set. 11, 21. And again, next it will take 2 plus 10, 20. Sorry, you are not 2 plus 10, 12. 2 into 12. 2 plus 10, 12. Again, 2 plus 20, it would become 22. It is giving like the sets. This is the map function. But flat map, what it will do the same, but it won't create it as set. It will give you flat answer. So it will be 13.
32 foot, 16 pounds, 40 foot, 20.
You're saying something?
What do you mean?
22. So, add a crap load of shit that would fit.
I'm adding things that are predicted to come in, right? And then she can clean it up as the time. Yeah.
It's just, I'm trying to.
Somebody saying something, or
That's
am I
it.
like, am I talking like, wait. Who was talking? Who is that? James, you saying something to me?
No, I'm sorry.
Okay, you are, okay, that's fine. So this is what we need to understand. It is like sets, but there it is a flat answer. For me, it took like 33, I am writing 23. We will get 11, 12, 13, 14, 21, 22, 23, 24. That is what the map. If it is a flat map, then you will get the same 11, 21, 12, 22, 13, 33, 14, 33, 23, 13, 23. I'm doing continuously multiplication. I don't know why. 14, 24. This is what the answer of flat map. Because you are getting in series. But here you are getting, this is wrong. This is 23. Here you are getting in sets. Only difference is that. And one more thing we need to discuss, that is set operators. So what are the set operators we are having? Okay, so any RDBMS. Set operators is nothing but different data, but same structure. Okay, joins are nothing but joins. Joins are nothing but different structure, different data, common column. This is nothing but join. Okay, set operators are having different data but same structure. Joins will have different structure, different data, common column. That what is that? We can see it. Okay. Now any RDBMS, any general like traditional RDBMS having all the set operators, you know that union all. Third one is intersection. Fourth one is subtract, right? So this is the RDBMS set operations. We are having union all, intersection, subtract. What is nothing but union? Union is nothing but where you are having no duplicates in RDBMS. No duplicates. So there would be no duplicates. But here, whenever you are writing in the big data or in PySpark, here also we are having same set operators, but here it would be in big data. Only difference is in big data or PySpark, we are having three. One is union, which is also nothing but union all. Both are same here. Union all means it will allow duplicates. Union all will have the duplicates. What is union all? We are having two sets. We are combining all the data. So it will have duplicates. But union don't have any duplicates. Union is nothing but only unique values it can be taken. No duplicates would be there in the union. But union all, it will have the duplicates. In PySpark, union and union all both are same. You will have duplicates also. It will allow you. Second one is intersection. That is common. Same for both. Third one is subtract. This is common. These two are common in any RDBMS or in PySpark or in big data. Only thing is union all. We are having same meaning. It means which allows the duplicates. That thing you need to understand. So I'm taking 5 more minutes. Okay. Union is nothing but what? Union is nothing but matched plus unmatched data. So union is nothing but matched and unmatched data. Means whatever data you are having, that will come here. All the data. Suppose if I'm having 2 data sets. In this data set, I'm having 1, and again in the data set also I'm having 1. Whenever you are trying to do the union all, you will get 1, 1. Suppose I'm having 1, 2, 3. Okay, like this I'm having. So what would be the answer for union all? It would give you 1, 2, 34, again 2, again 1, again 45. In this, what you are understanding? So it is having the duplicate values. 1 already there, 1 again, 2 already there, 2 is coming again. So this is what the duplicate values. Whenever you are getting the duplicate values, you are having one function called distinct. So in this distinct function, it will remove the duplicates. It will remove the duplicates. But distinct is Y transformation. So if you if you seriously require that, then only we need to use the Y transformation. So if you are not required anything, it is billing, right? Everything is comes under billing. So if I use Y transformation, the cost of the transformations are going to be increased. The billing is going to be increased. So if you really require any transformations wide, then only you can use it. If it is done by single, like what you call narrow transformation, then you can use the narrow transformations only. That is what the good data engineer must do. So you need to analyze your transformations, what you are doing. If your transformations are done by your narrow transformations, always prefer narrow. If it is not done by narrow, then only go for the wide transformation, because narrow transformations are cheaper than wide transformations. That is what we need to remember. I'm just trying to create two. I'll finish it in 5 minutes. Anyway, we have started this concept. I'm trying to create two RDDs. RDD1 equals to SC dot parallelize giving one list 1, 2, 3, 4, 5, 6, 7, giving 3 partitions. RDD2 SC dot parallelize five comma 6 comma 7, 8, 9, 10. I'm giving the 3 partitions. Trying to create 2 RDDs. I have created it. I'm not using any collect function. That's why it is not displaying. Okay. So just I'm trying to do the union. What it will give you. Union RDD1 dot union. Inside that, which RDD you want to give, that you need to give RDD2. Finally, just collect that. Okay, this giving duplicate data also. 7, 5, 6, 7 already there. Again, it is giving 5, 6, 7. This is what the union and union all both are same in. So if I'm writing union in PySpark, it means that union all. That's it. Only one thing we are having, that is union. Next, try to intersect this. And let me check whether this is narrow or wide transformation. No shuffle right, shuffle read, narrow transformation. Again, now RDD1 dot. I just want to use intersection. Intersection RDD2 just collect it. Let's understand. Shuffle read, shuffle write happened. So this is a Y transformation. So intersection is nothing but Y transformation. How it is working, you can see here in the DAG scheduler. This is a DAG visualization. So what happened? It has taken 2 RDDs, both are parallelly, and it is union. And after doing the union, what it was doing, it was partitioning by using a map function inside, and it is giving you the intersection. So this is what done in the intersection. You are having, it is parallelized. Why? Because we have given RDD parallelization, right? SC dot parallelize. It has taken parallelly all the elements and then it is unioned together. Means what? It came into this result set 1, 2, 3, 4, 5, 6, 7. And what it is giving? It is doing some partitioning and mapping. Then it is giving the answer. We can see here. I'm just intersecting this, and you don't confuse with this. This is different spark job. This is different spark. 6 and this is 7. So what it is doing? First, it is doing all this union here only, not in this 52 cell only. The work is like this. So in this, what it was doing? 6, 7, 5. 6, 7, 5. Only intersection has given. We are having this 2, 1, 2, 3, 4, 5, 6, 7. 5, 6, 7, 8, 9, 10. Where it is intersecting? Here. 5, 6, 7, 5, 6, 7. Common one. It is giving the common one. Intersection is nothing but what? We are getting the common one. You know, right? Intersection, this things, this part. This part is the intersection, which is nothing but in both the sets. It is the common one. Common one is there 5, 6, 7. If it needs to get that, it needs to collect all the data from this set and this set. It will collect and it will separate this data. That's why this is Y transformation. You can see it is a Y transformation because how many number of stages it is there? Two number of stages. All here we are having one stage. But here you are having 2 stages, means which is a Y transformation. Clear? Let's try to do this gloom, then how it is separating we can understand. One, two, three, four, five, 6, total 6 partitions. Into the 6, we are not having this 3, we are having only 3. Why 6 partitions? RDD1 is 3 partitions, RDD2 is
3 partitions.
3 partitions. 3 plus 3 is 6. It has given the space for 6, but we are having 3 elements. That's what the intersection. So intersection is nothing but just try to give the subtraction, how it will give. One, 1, 2, 3, 4. You are getting here. And let's check. This is also Y transformation. What it was doing? It was unioning. Again, from there, it is doing the map function, partition by map. So you are having shuffle read and shuffle write. Okay. This is what? Y transformations. We are having all these things. We are receiving subtract 1, 2, 3, 4. So this is nothing but Y transformations. If it is exchanging data from one partition to another partition while doing transformation, that is nothing but shuffling, right? If it is exchanging, I'll write it here. If it is exchanging data from one partition to another partition while doing transformation. In simple way, if I want to say what is shuffling, So if shuffling is happening, that is wide transformation, and you will get unique data. Subtract also wide transformation, distinct also wide transformation. Shall we check distinct also for a while? Here, what is happening? We are having this one, right? These two data sets, you can say it. These two RDDs, you are having this data. What is happening to this data? The data is shuffling through the partitions. Even you are having 6 partitions or 4 partitions or anything. Through that partitions, it is shuffling. So this is nothing but this kind of things are nothing but wide transformations that you need to understand. Let's try to create one distinct function. Then let's check whether how it is doing. RDD1, I'm using union. Where we'll use distinct function? If we are having duplicates, okay, you need to remember. So in union, we are having duplicates, right? Here.
Yeah.
We are having duplicates. So that is why I'm using the same function. RDD1 union RDD2 distinct. Next, do it gloom to understand the partitions. Collect it. If I'm not you. So you are getting distinct 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But what is union? Union is having 5, 6, 7, 5, 6, 7, which is duplicate. This duplicate is removed here and you got only unique values. Only unique values. These are given into 1, 2, 3, 4, 5, 6, all 6. Because we are having the data in all 6 partitions. When you are doing the subtract or another one, which one? Intersection, you are not having that. So let's check how many spark jobs are there. Total 2 stages. Distinct is a union is narrow. Narrow. Union is narrow. Distinct is wide. Why? It will union first and again it will see the partitions. Let's check here. Union, again partition by mapping. This is what the intersection. Distinct is used for eliminating duplicates. Distinct is a wide transformation. Tomorrow, in tomorrow class, we will see what is repartition and coalesce. This is the most important question in all interviews. Repartition. Without this question, no Spark interview would be there. No PySpark interview. Coalesce. This is very important topic. Don't skip tomorrow's class. Because all interviews, they will ask you what is the difference between repartition and coalesce. I'll give you a brief. Repartition, which is a narrow transformation. Coalesce is wide transformation. Both are adjusting the partitions only. But we'll see in the next class. Any doubts till now? No? Okay. Okay. Then thank you. I'm not leaving.